And at the top of page 180, we have this idea. We're going to find out in 3.2, what do negative signs do? And you've learned about negatives already when you did parabolas. Remember that an x squared parabola opened up, and if you had a negative x squared, it flipped it and opened down. So with parabolas, we've already seen that a negative outside of a function flips something down. With a parabola, we actually never flip something horizontally, because if you imagine a parabola, the regular parabola, and you flip it horizontally, well, it's exactly the same as it started with. So it wasn't necessary. But it will be necessary for some of the graphs that we do. So what we're going to look at now is, what do negatives do? And in the first one, it says, let's look at what happens if you have a negative outside of the function. So do you see how it's y equals negative f of x? That's outside of the function. So far, outside has always affected things vertically. And that will be the same here. We're also going to find out whenever you affect something vertically, you're only changing the y-coordinate of points. So if I take this red graph and I flip it vertically, it would go down there. And if I took that point 8, 4, and I flip that point down, it's now going to be at 8, negative 4. The only thing that's changed is the y-coordinate has gotten multiplied by negative 1. Similarly, if you had the negative inside the function, like f of negative x, now negative, everything inside is horizontal. This will do the same thing, but now it will multiply your x-coordinates by negative 1. It will reflect it over the y-axis, like this. And if you imagine that point 8, 4, if it gets flipped over, it would now be at negative 8, 4. And only the x-coordinate would get changed. So what I'd like you to do is, in the space beside that on page 180, I'd like you to write the following. First of all, with the negative outside the function. And sometimes, most common, we'll put the negative right in front, but sometimes you'll see it on the other side with the y. And I hope you can see that those are identical. You could get them by just multiplying both sides by a negative 1. So if the negative is outside the function, in other words, it could be considered with the y, then this is a vertical reflection. And vertical reflections are always over the x-axis. If you take a point and flip it over the x-axis, only the y-coordinate will change. And algebraically, what you'd have to do is take that y-coordinate and multiply by a negative 1. If the negative is inside the function, in other words, the negative is with the x, then this would be a horizontal reflection. You would reflect things over the y-axis.
Sorry for the interruption. Grade 11 students, last call. If you are a French immersion student that is in an English class right now, please make your way down if you're grade 11 to the theater. English grade 11 students, please make your way down to the gym. Last call.
And what that means, algebraically, is that your x-coordinates are going to change, and they're going to get multiplied by a negative 1. This is the one time that inside the brackets with the x, it doesn't do something crazy opposite. The negative does exactly what you think. It multiplies by -1 for both the y and for the x. So I'll just give you time to finish writing that up, and then we will be ready for example 1. All right, is everybody done? So let's go to example 1. And in example 1, it says, here is the graph of g of x. Sketch the image after a reflection in the y-axis. And what I'd like you to do first is I'd like you to underline this part, a reflection in the y-axis. Because with reflections, there's a number of different ways they can ask you the same thing. So they could say a reflection in the y-axis. Okay? That would be a vertical reflection. Sorry, no, that would be a horizontal reflection. See? Great start here. Because you're going over the y-axis, you're moving things horizontally. So I could ask this same question by asking for a horizontal reflection. It could be asked as a reflection over the line x equals 0. So your y-axis has an equation. The equation of your y-axis is x equals 0. They could also give this to you in function notation, and since it's a horizontal reflection, the negative would be with the x. So one of the things with reflection questions, they'll ask it of you in one of those 4 ways, but you have to have all 4 of those things in your mind every single time. So you're like, okay, it's over the y-axis. What's moving? I'm moving left and right. If I go over the y-axis, that's horizontal. So that's a horizontal reflection. That would mean that my x values have the negative, and I multiply my x values by -1. Now, if we look at what's happening here, I'm reflecting over the y-axis. Starting with this point on the left, it's 3 away from the y-axis. So if I reflect it over, it would be 3 away on the other side. This point is 1 away, so it would be 1 away on the other side. This one's 3 away from my y-axis. And this one, 1, 2, 3, 4, 5, 3, 4. So we could just count out the points to reflect it. That's not very hard. You could also see if you actually wrote the coordinates down. This point here is 5, 2. When I label it over here in blue, on the blue graph, notice your x coordinate changed. It got multiplied by a negative. Your y coordinate didn't. Same thing I could do with other points. Maybe I choose this one here, -3, 1. On my other graph, that'd be 3, 1. And we just have to connect the lines. Can you see? Here's my y-axis. Can you see that the red graph has been flipped over and reflected over that y-axis? Question also says to state the domain and range of each function. For this one, I'm going to use interval notation this time. So remember, domain are your x values. If I wanted to start with my smallest x value on my red graph, can you see that your smallest x value is -3, and your biggest x value is +5? So it goes from -3 to 5. And your range, the smallest y value is -2. Your biggest y value is +2. On my blue graph, my domain, my smallest x value is now -5. My biggest x value, +3. And the range coming from the bottom, smallest y value is -2, and biggest y value is +2. Some patterns to recognize. Notice the range stayed the same. Why did it stay the same? Well, if we were doing a reflection in the y-axis, right, algebraically, we're multiplying our x value by -1. We are not doing anything to the y value. So if your range describes your y values, it should make sense that they stayed the same. Nothing changed. But look what happened to our x values. They did change. Can you see that they've been multiplied by a -1? Your smallest value, which was -3, if I multiply that by a -1, it becomes my biggest value at +3. And my biggest value at +5, when I multiply that by -1, becomes my smallest value at -5. So I'd like you to circle questions, write down first 3 and 13, and then go to your homework and circle questions 3 and 13.